All right, we're going to again review really quickly. So section 4 is about the slope in the plane. So very quickly, these four slopes, what kind of slopes are they? Go ahead and write that in the box. So usually I see that people don't have problems with these three except for this one. So the up and down is undefined slope. And then if it goes left and right, that is zero slope. So don't get those two confused. So what is the slope definition? Well, slope, if you kind of remember the formula, is y2 minus y1 over x2 minus x1. And another way we remember that is rise over run. So it's how much you go up and down divided by how much you go left and right. And so in another way, when we're saying y2 minus y1, we're saying how much is y changing. So then in math and a lot of times in like chemistry, we say change by this triangle symbol. This is actually, there's a name for that in Greek. This is called delta. So then we would say delta y over delta x. Okay, so that is slope. So really quickly. And the second thing is that y-intercept. So kind of vocab review again. Y-intercept is what? Y-intercept is when x is 0. So when is x going to be 0? When it crosses the y-axis. So really quick definitions or review. So let's just practice. How do you find the slope between these 2 points? So y2 minus y1 over x2 minus x1. It doesn't really matter which one you make the first point, which one you make the second point. Let's just say this way. So y2 is negative 2, y1 is 2, and then x2 is 4, x1 is negative 1. So then we get a negative 4 over 5. Now, if you recall that there are a few ways that we can write equations of a line, one of them is called the point-slope form. And that is because there is a point and a slope. So the formula is y minus y1 equals m times x minus x1. Where is the point and where is the slope? The point is here, x1, y1, and the slope is m. The second form that we use a lot is called the slope-intercept form, because there is the slope and the intercept. Now the question is, what intercept is it? So slope is this one, intercept is this one. What kind of intercept is this? This is the y-intercept. There are two more forms that's not used as often. Like you would see equations in this form, but you don't actually usually write it in this form. The third one is called the standard form. That is ax plus by equals c. And in this case, a, b, c are integers. So if you recall, that is in whole numbers with their opposites as well. But also a has to be positive integer. So you can't start the equation with a negative number is what they're saying. The fourth one is called the general form. Which is ax plus by minus c equals 0. And so ABC follows the same idea as number 3, the standard form. All right, so let's go ahead and solve a problem really quickly. Find the equation of the line passing through these 2 points. And we're going to do that in both methods. So you can choose whichever method you like. I usually use the point-slope form because it's faster. All right, so if you want to find a line that passes through these 2 points, no matter what you do, the first thing you have to do is find slope. So slope y2 minus y1 over x2 minus x1. So 3 over 1 is 3. So slope is 3. Next, let's say we start with point slope form. Then we start with the equation. And then what we do is we plug these things in. Okay, now the question is, which point should you choose? Answer, doesn't matter. I just choose the one with a smaller number, so it's easier to calculate. So I'm going to use 2, 1. So that means y1 is the y part of that point. So 1 equals 3 times x minus 2. So this is y minus 1 equals 3x minus 6. So y equals 3x minus 5. So this is the answer there. Let's say you start from slope intercept, which is something that a lot of people like as well. It really doesn't matter. What you would do is you would substitute in m, so that's the slope, and then you need to substitute in x and y so that you can find the intercept. So I'm going to use the same point again. So 1 equals 3 times 2 plus b. So 1 equals 6 plus b, so that makes b equals negative 5. The last thing you're going to do is plug it all back into the equation. Y equals 3x minus 5. So same equation, no matter which method you do. All right, really quick review. Parallel lines. Parallel lines have what kind of slope? They have same slope. And then perpendicular, so perpendicular versus parallel. Perpendicular lines have what kind of slope? Because of the 90 degrees, they have opposite. So remember, opposite means opposite signs. Reciprocal. Reciprocal means divide that number by 1. So perpendicular lines have opposite reciprocal slope. So let's look at the following question. Find the parallel slope and perpendicular slope of the following lines. I'm going to do the easy one. You can do the a little harder one. So this one is already in the form of y equals mx plus b. So very easy. We just need to find the slope of this line, which is just a direct matching game, right? So slope in this case is negative 4. So then if it's parallel, then it must also have the same slope. If it's perpendicular, it must have the opposite, which means the opposite sign makes it positive. And then reciprocal means flip that over, so 1/4. Now it's your turn. Find the perpendicular slope, parallel slope and the perpendicular slope. The first thing you have to do is you got to change it into y equals mx plus b. Give that a try, pause the video, and come back and check. All right, the parallel slope is 3/2. The perpendicular slope is negative 2/3. All right, really quick practice. So I'm going to do the first one. You're going to do the second one. Find the equation of the line through this point that is perpendicular to this line. So if we want it perpendicular to that line, we better find out what slope it has. So put it in the y equals mx plus b form. Y equals negative 4x plus 3. So m is negative 4. We want it to be perpendicular to this line, so then perpendicular slope is going to be 1/4. So we want a line to have that slope 1/4 and goes through this point. So you can use any method you want. I like the point slope form, so I'm going to do y minus y1 equals m times x minus x1. So this is y minus y1 equals m times x minus x1. So y plus 3 equals 1/4 x, and then 1/4 times negative 2 is negative 1/2. So then subtract 3 on both sides. y equals 1/4 x, and that is minus 3 and 1/2. Or we really don't like to mix mixed number with fractions. It's just a very awkward way of looking at it. So I just turn everything, I'm sorry, forgot the x. I just turn everything into improper fraction. I think that's just looks better. So this is the answer. What if they said they want the answer not in slope-intercept form, but they want it in, let's say, standard form? Remember that standard form means you have to have all integers. So this is not going to work. So then what we want to do is then multiply everything by the least common denominator so we can get everything into integer. So then this becomes 4y equals x minus 14. Okay, 14 because the 2 in the denominator cancels with this 4. So we have a 2 left over, and that multiplies. And then the next thing is, if you recall, the standard form is ax plus by equals c. So x and y are both on the left, so this x needs to go. Minus x plus 4y equals minus 14. And then the last criteria is that a has to be positive. So in order to make that positive, I got to multiply by a -1. So this is x minus 4y equals 14. So this would be the same equation in standard form. And if you were to change it to general form, then you would just move that 14 over. Okay, so just so that you know how to get it into any form you want. All right, so now let's have you practice. Find the equation of the line through 1, -2 that is parallel to the line with the equation 3x minus 2y equals 1. You can write it in any form you want. All right, go ahead and check your answers. These are the 3 forms that you would probably have your answer in. All right, and section 5, we're going to review again really quickly. What does a solution mean? Solution means a few things. So like, a lot of times people say, solve this problem, find the solution. What do they actually want you to do? Well, solution of an equation means the x-intercept. And why is that the x-intercept? Because it's the x value that makes the equation equal to 0. And equation equal to 0 means y equals to 0. So x-intercept, if you recall, means it's when the graph crosses the x-axis. So what are some words we use to represent solution? So x-intercept is 1. Not every x-intercept is going to or not every solution will actually appear as an x-intercept because there may be answers to the equation or like the solutions to the equation, but in order for it to be an x-intercept, it has to show up on the graph, right? There are some answers that's not going to show up on the graph, and if you kind of remember that from last year, that would be your imaginary numbers, right? You can find it algebraically, but it's not actually going to show up on the graph because it's imaginary. It doesn't exist in real life. But anyways, I digress. So solution, x-intercept is another word, or we can also say zeros or roots. So those all mean the same thing. Just remember, all of these words are asking you the same thing. What x value will make y 0? Okay, so let's try this question. 2x squared minus 3x minus 2 equals 0, and we're going to solve it. So, all right. We're at the point where we're doing quadratic equations. So quadratic, remember, means degree of 2, and that is nonlinear because once you have any degrees higher or not equal to 1, you have quadratic. All right, let's try to solve it by factoring. So if you recall, when the leading coefficient is not 1, the factoring gets a little bit trickier. So depending on how you remember how to do it in the past, stick with that method. If you don't remember how to do it in the past when the leading coefficient is not 1, here's kind of a little trick. So what you do is you first multiply a and c together. When I refer to a and c, I meant each quadratic equation is always in the form of ax squared plus bx plus c. So a is the leading coefficient of x squared, c is the constant. So you multiply those two together. So in this case, you're going to get a negative 4. And then you ask yourself, how would I get a negative 4 from the middle? What two numbers multiply together to get negative 4? When I add them, I get a negative 3, is my question. Sorry if that was very unclear. So what two numbers multiply together to get negative 4? When you add them, you get negative 3. I'm going to say negative 4 and positive 1. So they multiply together to get negative 4. When you add them together, you get negative 3. So what I'm going to do is I'm going to split this negative 3x into negative 4x and 1x. So I'm going to rewrite this problem. So instead of negative 3x, I'm going to split it into those two coefficient that I said would multiply together to get negative 4. And then when I add them, I get negative 3. All right. And then what I'm going to do is I'm going to do grouping like this. And then I'm going to factor out the greatest common factor out of every group. So if I look at the first group here, the greatest common factor I can take out is 2x. I'm going to take out 2x. So what factoring means is that I'm going to take out 2x means divide every term by 2x. So then this term has x left over. And then this term has 2 left over. And then I look at my second group. X minus 2, there's nothing in common between the two terms, so there's nothing to factor. So I'm going to just leave it alone. Then I look at this really big group. 2x times x minus 2, that you can think of it as one big term, plus x minus 2. And then you ask yourself, what is the biggest thing I can take out of this whole thing? Well, the thing that's actually repeating is x minus 2, right? So then what I can do is take out x minus 2. So if I take out x minus 2 from here, what's left over? 2x. If I take out x minus 2 from here, what's left over? 1. I hope you didn't say, just said 0. So this is the answer. This is the correct factoring. So once we factored it correctly, then we need to still solve. That means each term is equal to 0. So x minus 2 is 0, or 2x plus 1 is 0. So x is 2, and x is minus 1/2. All right, that's solving by factoring. The second way is complete the square. So this one, people have trouble remembering this every single year, so let's just review. To complete the square, what we do is we first throw the 2, or the constant, to the other side. And we cannot have a leading coefficient, so I'm going to take the 2 out. But if I take 2 out, I got to take 2 out of every term. So then I have an x squared minus 3 over 2x. Now I'm going to complete the square, so I'm going to add a magic number there. And then whatever I do to one side, I have to do it to the other side. But I cannot just add a magic number. I have to put a 2 in front. Why is that? because there is a leading coefficient of 2. So essentially, I was actually adding 2 boxes. So I got to add 2 boxes there. What goes inside the box? The box is b over 2 squared. What is b? I'm asking a lot of questions. What is b? b is this part. Remember, it's ax squared plus bx plus c. So then in this case, we would have negative 3 over 2 squared. All right, a lot of little algebra details here. How do you divide negative 3/2 by 2? Well, you would think of it as you're dividing by 2 over 1. So then you can just think of it as dividing by 2 over 1, which we know if we have a fraction divided by another fraction, it's multiplied by the reciprocal. So then this becomes negative 3 over 4. Okay, so this is 9 over 16. So hopefully you'll get better a lot this year by just practicing that. You don't need to write this whole thing out every single time. That's very time consuming. So what happens is you could just in your mind think of flipping that 2 into a 1/2, and then the denominator is here, 2 and 2 multiplies together, which gets you that 4. So it just takes practice, and then you'll become faster. All right, so the magic number is 9 over 16. So 9 over 16 goes in there. All right, factor. So 2 times, that's very hard to factor. So what should we do? Well, very easy. It's always going to be b over 2. It's always going to be b over 2. So that's going to be x minus 3/4 squared. All right, let's solve this right-hand side. So 2 and 9 over 16, that's going to cancel. We get an 8 there. So that's 2 plus 9 over 8. We need a common denominator, so we're going to multiply by 8 over 8 here. So that is 16 over 8 plus 9 over 8, which is 25 over 8. All right, so complete a square is a necessary method, but it does take a lot longer than usual. All right, we get to this point. We got to solve for x. So we got to first divide by 2. All right, another fraction divided by integer. So x minus 3/4 squared is equal to 25 over 8 divided by 2. So 25 over 8 divided by 2, that is 25 over 8 divided by 2 over 1, which is 25 over 8 times 1/2, which is 25 over 16. Square root that. When we square root this, we get x minus 3/4 equals 5 over 4. Is that right? No. Plus minus. Every time you square root something, you have plus minus. So x is equal to 3/4 plus minus 5 over 4. Okay, when the numbers are easy like this, please don't leave it like this. You should solve it. So one of the answer is 3/4 plus 5/4. The other answer is 3/4 minus 5/4. So 3/4 plus 5/4 is 8 over 4. That's 2. 3/4 minus 5/4 is minus 2 over 4. So that's minus 1/2. Oh, we're finally done with complete a square. All right, the last one is quadratic formula. So I'm going to rewrite this problem again. To use the quadratic formula, make sure you're in the quadratic form first. Okay, so quadratic formula, if you don't remember, is to solve x. That is negative b plus or minus square root of b squared minus 4ac all over 2a. So this is negative b plus or minus square root of b squared minus 4ac all over 2a. All right, let's solve this. 3 plus minus square root of 9 plus 4 times 2 times 2. So that's 16 over 4. 3 plus minus square root of 25 over 4. That is 3 plus minus 5 over 4. All right, 3 plus 5 is 8 over 4 is 2. 3 minus 5 is negative 2 over 4 is negative 1/2. All right, now is time. Now's the time for you to practice all three methods. So go ahead and give this a try, and then come back and check the answer. All right, so no matter what method you use, you should end up with x equals 1/3 or negative 4. All right, let's have you try this last one. This one you have to use quadratic formula. Okay, the answer is x equals square root 3 plus or minus square root of 23 over 2. Now, you can find a solution if you have a linear equation or a quadratic equation, but what if the equation is not any of those? How would you be able to find a solution? So what we would do is we would use graphing calculator or decimals. So for example, this one, if you were to solve this one, what you would think of it is, or how you would think of it is that this side, you would think of it as an equation, x cubed minus x minus 1. And this side, you would think of it as another equation, which is y equals 0. Y equals 0, remember, is really just the x-axis. So it's really asking the question, when is this graph crossing the x-axis? At which x value is the graph crossing the x-axis? So this question is not something we can solve by factoring or any algebraic method. So we're going to go to the graphing calculator to solve. So we're going to do a lot of graphing calculator this year, so make sure that you have it next to you so you can practice. Okay, so the first thing you're going to do is turn on the calculator. And then all right, so what you do is first you would go to this button, y equals. This is where you go pretty much all the time to enter equations. So once you click y equals, you would see y1 equals, and then you would enter in the equation. So the equation we want is x cubed minus x minus 1. So to find the x button, that is this button here. This is the variable button. So once you click that, you're going to get an x. And then what you're going to do is tell it to cube. To cube, what you would do is go to this button. This is called a caret. So basically, it does all the exponents. As soon as you click it, if you're in the TI-84, then it should come out with an exponent like this, and then you can type in 3. And then you just put minus, and then x again, minus 1. That's it. And then after that, you're going to click trace. Trace is kind of like your graph. You can either click trace or graph. It's kind of the same. Trace allows you to follow the graph, like your cursor is on the graph. Graph just means that you see a graph, your cursor could be anywhere in space. So I think trace is probably much better. All right, so I'm going to graph it on my calculator as well so I can see what you're seeing. So you probably would be looking at, oops, sorry. Oh, that's not what I want. So your graph probably looks something like this. So you can see that this is the only solution. And we need to figure out what that number is. So here's kind of the thing to solve that. What you're going to do is you're going to click on second first and then trace. The reason you do that is that here, when you click second, that is the blue button, so then it calls out the blue function. The blue function says calc. Calc means calculate. So then when you click on that, you're going to open up a list of functions. So it says calculate. And then the first one says value. The second one says 0. So 0 is the one you want because we're trying to figure out where it's crossing the 0 or x-axis. So click on that. Number 2, I usually just type in 2. Saves myself some time. The screen says left bound. That means where is the left-hand side of this 0? So then depending on where your cursor is, you're going to move left or right on the calculator, and then the cursor is going to move with you. And so what you want to do is you want to be on the left of the of the 0. So the left of the 0 is basically below. So once you're kind of close to below the point, you click enter. And once you click enter, your calculator is going to have a little arrow like this. That means this is the left-hand side of where you want me to find this value. And then now your calculator is going to say right bound. So they're saying, well, where do you want me to stop checking? So I want my cursor to be somewhere here. So I'm going to go to the right. Once I'm somewhere on the right of the 0, I click enter again. And then I'm going to see this arrow that kind of locks between the two arrows pointing towards each other. And then the last thing it's going to ask is guess. So guess means, where do you think the real 0 really is? I don't really play a lot with it. I just click enter anyways. Then your calculator is going to say 0. X equals. And this one has a lot of numbers. So this one says 1.324718. And how do you know this is a 0? Because it says y equals 0. So please do not just trace your graph and then just like randomly, get as close as you can to the x-axis, because y is not going to be 0. So let the calculator calculate for you. All right, so this is the answer for this question, which is x equals 1.324718. You can stop at 3 digits, so 1.325, round up, and that would be perfect. All right, so let's look at this question. When is this equal to this? So we can think of it in 2 different ways. We can do it graphically, or we can do it algebraically. So I'm going to show you both ways. Let's do algebraic first, because we've already know how to do this for a long time. So absolute value 2x minus 1 equals 6. What we can do is first take out the absolute value bar, so 2x minus 1 equals 6. And then we take off the absolute value bar, but then we make the number negative. And then we solve. 2x equals 7, x equals 7 over 2, or 2x equals negative 5, x equals negative 5 over 2. So 2 answers. Now we're going to look at how to solve this graphically. So remember, 2 sides of an equation, you can kind of think of it as 2 independent equations. And so when we're looking at this, we're basically saying, when is the absolute value graph crossing with the line y equals 6? So the absolute value graph, let's make it green. And then the y equals 6 line is this one. And so when it's asking you what are the 2x values where this crosses, we're just saying these two. So pretty easy to see. Now, if we want to actually use the graphing calculator to solve this, you really don't want to, excuse me, you really don't want to have two equations that you're graphing and then you're saying, calculator, please figure out the intersection. Because on the graphing calculator, that can be a little bit cumbersome. So what I would suggest is that every time you're using the calculator to solve something, using a graphing function, you should always change the equation so that it is not a number on the other side. You should always change it so that it's 0 on the other side, because then you're comparing everything against the x-axis, so it's easier graphically to visualize that. So if you do that, then the graph would actually just basically, in another way, shift down. So instead of this graph, I don't think I can make that smaller, so I'm going to redraw this one. So this is comparing the square root 2x, absolute value 2x minus 1 and then minus 6 graph compared to the x-axis. So what's going to happen is you're going to have a graph that looks something like this. And then you're comparing it against the x-axis, so then you're really just looking at those two intersections. And then to find the zeros or the intersections with the x-axis, you would do the same method that you had done before. All right, let's go ahead and have you practice one. So this one, let's just try this the algebraic way. So what is the answer to this? This is a little bit strange because you've probably never seen anything with the absolute value with a quadratic inside, but it's the same idea, except you need to make sure you plug the answer back into the equation to check if it's a real solution. Because in this question, we just want the real solution. We don't want the imaginary answers. All right, go ahead and pause the video and try this one. All right, we have actually 4 answers, but this is the only one that's real, and that's the one that they want us to include. The other 2, they have an I in there, so that is imaginary, so they don't want those solutions. All right, so the last thing is this part. So if you're solving absolute value questions, just make sure you first this is algebraically. You isolate the absolute value part, you make it equal to the positive and negative of the answer, solve it, and then you check the solution.